Hey, Mr. Kern here. This is lesson 24, electron configuration. Basically, if that scares you, it's the electron cloud model. So we talked about different models of the atom. There was the Bohr model that we've been using. This is the more correct version, and we'll look at what the differences are. In particular, it's the idea instead of shells, like the Bohr model had, we have subshells. So shells nested within other shells. Now this is the short version of the notes because there's a 24-minute video that I didn't plan on it being 24 minutes, but it is. It's the whole entire package of what you need to know about this stuff, of how to go over all the types of problems. This is going to be a kind of quicker, simpler version without it getting too complicated. Now, if you know you're going to want to see the other one with all of everything, and you want to basically be a little bit ahead in class, I would just go watch that one, or at least watch the first half of it or so. If you want to just get the minimum and do this for next time, that's fine, but realize there's a whole lot more out there that you should be watching too. Okay. So, with this, instead of looking at, if we're going to draw a picture of fluorine, so I'm going to pause this and draw a picture of fluorine. You can too, if you want. So when you're drawing these, they've told you forever that there are 2 electrons on the first shell. Why are there 2 electrons on the first shell? I don't know, there just are, which is kind of an okay answer at some levels, but if we want to be totally correct, we should maybe know why. So altogether, it's 9 electrons, 2 on the inside, 7 on the outside. But the big question is, why are there only 2 there? Why, well, I guess, what's the number that you can fit on the outside? The biggest number is 8. Eventually, though, we'll see problems. That's what's on the second video, is how to get the right number of electrons when you have something like that, because you don't know how to draw that correctly, because they didn't tell you the right way to do it. They told you the thing that was good enough for what you had right now. So the difference is, instead of looking at the Bohr model with the shells, we're going to look at orbitals. That's what the electron cloud model is. So instead of rings with the different layers of electrons, there are more 3D shapes where they're able to travel. So the s orbital is this one, is a sphere. Each of these little shapes on here, there can be 2 electrons inside. So for the s orbital, it will hold 2 electrons. That's all that an s orbital holds. P orbital, there are 2 electrons that are not necessarily doing figure 8, but they're moving randomly within there. So p orbitals will hold 2, 4, 6 in total. D orbitals, so 2 electrons live in all of these. So 2, 4, 6, 8, 10. F orbitals will hold 14 electrons. That's how many electrons are held in each type of orbital. So if you have more of these orbitals, you can hold more electrons. So if the first shell only holds 2, that is because, if we look on this slightly different periodic table, the first shell is only made up out of an s orbital. So all that fits in the first period is just 2 electrons, because the first period is, instead of just being a ring holding 2 electrons, it's a sphere holding 2 electrons. If we compare that to the other shells, the second period, the second shell, has an s orbital and it has a p orbital. So the s orbital holds 2, the p orbital holds 6. So altogether, how many electrons can we put in that shell? We can put a total of 8, which is, like we already knew, you can hold 8 in a shell. If we look at the third shell, the third period, you have an s orbital holding 2, you have a p orbital holding 6. That's as far as we're going to go on this video. On the other one, it goes all the way to explain how to do things with these and why that's a 3D and what it means. So again, we're going to have to watch that later anyway, but if you're shooting for the minimum right now, that's okay. You can go with this. So the idea of subshells is that each of the Bohr rings is made up out of tiny shells inside it. So the subshells are the S, the P, the D, and the F. So if instead of drawing fluorine the way we did, if we drew it with these subshells in mind, it's going to look a little bit different. So when I draw these, I like to think of it like I'm just kind of walking somewhere, and I want directions to get to fluorine, which lives right here. So if you're given directions, start off with where you start off. We have to start up here. And so you're telling somebody how to get all the way through here and end up at fluorine. So we have to start by traveling through the 1S's, that whole area. So 1S, and how far do we go? We have to go through 2 of those. So we put a little 2 there. That's how we note that. So for our fluorine, our drawing, we have the 1S subshell, and we have 2 electrons on it. So the first one looks the same. But when we look at the second shell, it's going to be a little different. Because as we look at our second shell here, I also like to think of it as a typewriter, because a typewriter is the thing people used to type on before computers, and it made clunky sounds. Look it up. Google it. At the end of the line, it's going to ding and go back to the beginning. So now we're back over here again, traveling through this. So now we travel through the 2S level. So we write down, I went through the 2S level. I went through 2 boxes to get there. You'll notice some patterns of we pretty much always have to go through 2 boxes of S if we go through all the way, because these have to be built up before the later ones. So on our picture, we draw inside the second shell, so the whole green circle there is the second shell. Inside that, we have a 2S subshell, but also we're going to have another subshell around it. We're also going to have the 2P. So we traveled through the 2S's, we traveled through both of them. We keep traveling through the 2P's all the way up to the 1, 2, 3, 4, 5th one. So 2P, 5. We put 5 of them in the second period, the P block. So when we draw dots, we would have drawn 2 in the 1S, or the 2S, and then 1, 2, 3, 4, 5. So in total, we have 2 electrons here, 2 electrons here, and 5 electrons here. That in total equals 9. On our original drawing, our usual one for the Bohr model, it has 2 electrons plus 7, so that equals 9. So the total amount's the same. The only difference is we tell where these 7 live. They don't live on just the second shell. They live over here, and they live over here. So with that, see if you can do a drawing for magnesium. Actually, no, let's go sodium. See if you can do a drawing for sodium, and see if you can list out basically the directions to get to sodium. So, our regular picture would have 2 dots on the first shell, 8 dots on the second shell, 1 dot on the last shell, so that's a total of 11. Our picture with the subshells is we still have these 3 shells, but now we realize they're thicker, and so that way we can draw others inside. So for this one, it's just a 1S, and we have 2 electrons on it. It's the same thing. The second shell, we have 2 orbitals on it. So we traveled through the 1S, we put 2 electrons on. So 1S, we put 2 electrons on. Ding! Back down here, 2S. We need 2 electrons on the 2S. And then we keep traveling across to the 2P. We're going all the way here with it. So we go all the way through the 2P. So the 2P, we go all the way through it. There are 6 of them there. So on here, our 2P, we would have 6. So how many in the second shell? 8 altogether in the whole shell, which matches what we have here. on the last shell, you go barely into the 3s. So the 3s, we'll have that orbital, that subshell, and we only have one on there. So you end up saying 3s1. Altogether, we could look at this and say I've got 2, 4, 10, 11. That looks like a 4, that's an arrow. I've got 11 electrons according to this nice little list of directions. I have 11 electrons according to this. I have 11 electrons according to this. That tells you did it right. How many are on the second shell? Here I have 8. Here I have 8. On the second shell, that means that's all the ones that start with a 2. So I have 2 and 6, so I have 8. How many on the last shell? 1, 1, and 1. So with these, that first big number, that's the period number. That letter, that is the subshell. Or you can call it the orbital, or you could call it the block, like this is the S block. That little number up top, that is the number of electrons in that shell. So basically, it's just adding those and making them bigger and bigger and bigger until you get here. That's weird. We'll learn what that means. You can learn what that means by watching the other video. But it's really just the same process over and over and over and over. So this is what we call that scary thing at the beginning, the electron configuration. An electron configuration is just the directions to get to that electron. So if I said 1s2, 2s2, 2p6, 3s2, 3p1. Could you tell me what element that is? So let's find it on here, find it on your periodic table. So you might have to do some fast forwarding and backing up to make it work. So look for that real quick. So 1s2 takes me all the way through there. 2s2, 2p6, 3s2, 3p1. That lands me right there. Now the easy way to do this is just realize all you have to look at is the last thing. The last thing's address is 3p1. So just jump right down to 3p1. I already know how to get to Hiawatha. What I need to know is what's your address. So just tell me the address, 3p1. So 3p1 is aluminum. So this thing is an electron configuration. So in class, when I say, hey, what's an electron configuration look like? Like that's what it looks like. It's just that address. Okay, so you take care.